In question 2, it states a thin rod is to be placed inside a cuboid shaped box which has dimensions 6 cm by 8 cm by 12 cm. And in part A, we need to find the length of the longest rod that can fit inside the box. And in part B, we need to find the angle that the rod would make with the top of the box, i.e. the plane ABCD. Now the length of the longest rod is the same as the length of any of the longest diagonals within the cuboid. For example, the diagonal from E to C or H to B and so on. So I'm using the blue line from E to C to represent the length of the longest rod. And we now need to construct some right-angled triangles within the cuboid. So we have a red right-angled triangle, EGH, on the base. And we also have another right-angled triangle with vertices ACE. And of course CE represents the thin rod. Now applying Pythagoras' theorem to the red right-angled triangle, EG squared equals 8 squared plus 6 squared, which implies that EG equals 10 centimetres. Now applying Pythagoras' theorem to the other triangle with vertices ACE, EC squared equals 10 squared plus 12 squared. Therefore EC is equal to the square root of 244 centimetres. This is the length of the longest rod that can fit inside the box. Now in part B, we need to find the angle that the rod would make with the top of the box, i.e. the plane ABCD. So again, referring to the triangle, the right-angled triangle with vertices A, C and E, tan theta equals the opposite divided by the adjacent. So tan theta equals 12 over 10, and therefore theta equals the inverse tan of 12 over 10, which is 50.2 degrees. Note in this question, since a cuboid is a prism, the length EG is also exactly the same as the length AC.